Wow. After connection got disconnected, so last maybe 30-40 minutes is gone. Never mind, it's not that critical. All right. So let me start the pig, and then we will talk about anything else. All right. All right. So let me SSH. So here is the, you can say pig here, and you are connected. That's it. Now you are connected to pig. Here you can start with simple ls command. Ls command basically talks to HDFS. So a better way to talk to HDFS is actually via pig. Okay, we could uh, copy from local, and there are so many shortcuts here. Okay, you can say copy from local, copy to local, and cp, and delete everything. So pig also provide you, other than the standard query language, it provides you the HDFS commands. All right, so if you have to change, you can see this here. When I'm inside the pig, I'm actually talking to HDFS. These are the HDFS files, and you can see what does it say. It says that it's a directory, and here it's a file. Okay, it's a file, and it shows that there are 3 replication factor. Sounds good. So this is your pig, and it says grunt here. All right, you can SSH into, okay, SSH to the CloudX Lab hosts, any of. Okay, and all right, so in HDFS you have the permission to manipulate user, student. I mean, you have permission to manipulate your own folder, and the data has been uploaded to data in HDFS. Okay, so this is related to our previous cloud lab, so we will update it. Now if you want to run it in the local mode, so this pig -x local can actually run on your desktop as well. You can just download pig and export a variable called java home, and then you start running pig -x local. It's basically the way we were doing Hadoop MapReduce testing. It is the same emulation. Okay, it works without Hadoop installation, very useful for testing locally, improves the development pace, and we use pig for uh, pig for non-Hadoop processing. We can use pig for non-Hadoop processing using these kind of commands. All right, now there is a question from, let me now take the questions before I move forward. All right, so question from Ganpati is it interpreter based or compiler based language? It's very difficult to say. It's very difficult to say. You can say that it's interpreted language. Okay, it's an interpreted language. All right. How is it different from Python? Python is full-fledged fledged language. Okay, full-fledged programming language. Okay, while you can compare, while it's similar to SQL. Randir's question is, can Pig run on Windows? Yes, you can just download and do. All right. So Ganpati's question is, I'm going too fast. Don't worry, I'm not going too fast. I'm just skipping the parts which are too much theoretical, so that I get more time. I put more time into hands-on. All right. Now, Veena is saying when you do LS, it is showing HDFS. How do you do a local LS? You can't. To do a local LS, you will have to come out of the prompt and then do. I'm not sure if they've implemented exclamation, but yeah. And what does dir do? Yeah, dir is not there. Okay. So there is no way to do that. You can't. You have to use the local one. All right. Question from Sridhar is, can we use pig and avoid using MapReduce? Yes, mostly. Okay. So mostly the way it happens is you try to use pig or hive, and only in the cases when you are totally stuck, you are not able to get things done using pig or hive, you will create something called UDF, user defined function, using Java or Python, and then use those instead of completely moving to MapReduce. But in some circumstances, it is very much required to to use MapReduce. All right. But it does alleviate a lot of pain of writing code. So Sushant's question is, what is the use of pigletin without Hadoop? Okay, I mean it can act like a normal data processing system. The way we have SQL without Hadoop, in the same way. All right. Now, how do we exit? You can press type exit and you. Sorry. How do you exit? You can press Control D and you will be out of it. All right. Or you can. I think you can type quit. Is quit there? Let me see. Yeah, you can type quit or you can press Control D. All right, very good questions, Randhir. Thank you. On Windows, when you run locally, it simulates HDFS. So when you run locally, when you say ls will give the list of local files. Okay, so it will, yes, it will simulate the local file system as if it's in HDFS. Good. Okay, so what are those circumstances, Ravi? You mean to say this one, when to use Pigletin without Hadoop? Ah, yes, Ravi. When not to use Pig? Okay, thank you. Let me just. All right. So sometimes when you are doing really, really complicated stuff, in which if you do it through Pig, you will end up writing too many UDFs. Okay, you will end up writing too many UDFs. In those cases, you would actually write MapReduce instead of getting into Pig. So if you are writing too many UDF as in user-defined functions, which can be called from Pig. If you are doing so many user-defined functions, that means you should go back to MapReduce instead of trying to fit your problem into Pig. Okay. If your problem is not related to the data flow, if your problem is far more complex, like machine learning or or say Mahat, then you would like to do MapReduce. All right. So the command line argument, the one which we have used so far, is without any argument. Okay, so you can also let me just exit from here, and let's say I write my a dot script. You can write anything, or you can, as a convention, you can write pig. Okay, here let's say I'm saying ls, and I'm saying what um, say make directory test. Okay, so these are the two commands I have kept in this file. Okay, this, if we execute using pig, it will run it and do the job. You see, it did the ls and created a directory called test. Now if you go back to hdfs and check whether it has created a test, yes, it has created a test. Okay, so you can go and check in your hdfs. All right, so I think it has deleted. Yes, it has deleted. Sounds good. Sounds good. So it's quite easy to start using it. Now, sometimes you just want to execute one command instead of the full script. In those cases, you could simply say pig minus e and then give your command name. See that? So you can use pig in three ways. First, interactive way, whereby you will get a grunt and you can start typing your commands interactive way. Second, you write all your commands in one program, one file that becomes your pig script, and you can start using that. You can pass that as the first argument. But sometimes you just want to execute one command of pig, and that's it. In those cases, you can say pig minus e and your command name. All right. You can check the version of pig by saying minus version. Okay. And also you can see the options by putting minus h argument. So Pawan's question is, are we done with MapReduce? Yes. So question from Veena is, are companies using Pig or MapReduce mostly? They use both. In a project, you will realize that you will have to use both from time to time, because you will realize that some problems are better done via MapReduce, while most of the 95% of the problem can be very well done using Pig or Hive. We'll talk about Hive later. Hive is nothing but SQL query language which internally translate into MapReduce. So Sushant's question is, rather than command line, is it possible to invoke pig commands from any other program? If so, how? So you can actually do a system command you can execute saying pig minus e and then ls, right? You can do this way. So that's the easiest and dirtiest way of interacting with pig via any other program. All right. Although pig does expose some API, okay, pig does expose some API using which you can call pig from Java program. So Pawan's question is, can we have one example of MapReduce with database connectivity? All right. Let me just put it into to do because it will require a considerable effort. All right. I'll have to get back to you. Okay. All right. All right. That is the question from Ganpati. Let me go back a couple of slides. All right. You can see this difference. All right. So pig and MapReduce. All right. The difference is as if saying Java and SQL. Pig, you can say pig Latin is similar to SQL, while MapReduce is more like a programming language, proper Java kind of language. So in case of SQL, you can pass the commands like select this data, that data, filter by this, group by this. So the data oriented works are really, really quick. While exactly the same analogy. Okay. So in Pig, the data flow oriented problems are really, really easy and quick. While the complex problems which are not related to data flow are can only better done using MapReduce. It becomes fairly complex to do that using Pig. Okay, so when you think about Pig and MapReduce, you think about SQL versus Java, and you will get the idea. In Java, you can do everything, while in SQL, you can do lots of data-oriented works in a very efficient manner. Did it make sense to you, Ganpati? Well, so that is the basic difference. So as we go forward, the difference will become more clear to you as we go forward. All right. And when do we use pig and when do we use this also will get clear when as we go forward. Because right now, no matter how much I explain about pig, it will still stay like a black box to you. Therefore, I would like to get started, and then, and that's why I'm trying to avoid this kind of a detailed discussion. I'll just get into theory. You can memorize that theory right now, but you will understand it only when you try to do things. Okay. So can pig process large input data and does the computation? Yes, because Pig at the end of day is creating MapReduce under the hood for you. Okay, the way you were trying to write your own MapReduce, Pig, whatever pigletin you write, it gets converted into MapReduce underneath, and it will do the same way. The way you executed Hadoop jar, it will also do the same thing with Hadoop. Okay, so with respect to big data processing, it does the same thing. So Pawan's question is pig like shell script with additional command? Not really. The only command it exposes are the basic ls these commands. Okay, so it's not comparable to HDFS. Okay, so yeah, you can see these are the commands it provides. You cannot compare it with shell actually. Shell is far more powerful, although it looks like it is a shell command. So Vina's question is, my understanding is both Pig and MR can handle structured, semi-structured, and unstructured data. That's correct. We'll see these examples as we go forward. All right. Ganpati is saying looks like problems provided in assignment can not be solved via Pig. No, they can be. No, they can be. Only one problem of mirror DNA will have you will have tough time. Okay, so if you try to solve those problems, most of them can be done like a breeze, but only one will get stuck. All right. How can we execute make directory in single line command in pig? Okay, you mean to say like this, pig minus e and then say mkdir my directory like this. Now let's say pig minus e and say ls. You see, do you see my directory? Yeah, it has been created. So you put a single quote around it and you will be able to create. All right. All right, let's get going. All right, I hope I'm able to answer your question. But don't worry, things will become clearer as we keep on going forward. All right, so yes. The benefit of doing all of these classes is that you should generally open up your parallelly the terminal and start working. Sounds good? All right. So on the prompt, you can pass all the HDFS commands. Okay. Other than HDFS commands, other than the pig Latin we will discuss further. You can pass the HDFS commands, as well as you can kill the job. Also, you can execute an external script. Okay, so the basic construction of a pig program is each step is a processing step, and each processing step results in a set. So each processing step results in a new set, or in terms of the tuple algebra, we call it a relation. A set is called as a relation. Now, the only thing which is not a processing step is dump and store. We'll go into the details. So, your program is composed of steps, and most of these will result in another data set. It is case sensitive. UDF function is okay. So, pig script, the basic syntax, the keywords are case insensitive, while the external functions are case sensitive. All right. Now, multi-line commands, you can write multi-line commands here also. If you are at pig, you could say things like this, and it will get completely ignored. Okay. Or you could also do the single line commands like this, and that will be ignored. All right. All right. Now, question from Sushant is that rather than the command line script, can we invoke pig commands from any program? If so, how? So generally, what you do is you write your script in temporary file, then you invoke this pig command line. Okay, by providing the script. Even this Uzi will do the same thing. Okay, so when you stitch a big project, you will be calling pig, you will calling MapReduce, you will be calling others, and all of this would happen by making calls to these shell programs. Although pig does expose some API, you can have a look at the pig API. You can use that API as well. Okay, by including pig.jar in your project, you can start using pig's interface to execute the query. All right, you can do that. Did I make sense to you? No. All right, so you can there will be a pig.jar, you can include it in your project and can call the functions of pig the way the console is calling. All right, let's try to do something quick. First, let's check if this data is there or not. Okay, let's check this data if it is there or not. So let's say this looks good, and I want to see this. Yes, the data is there and it has something. All right, now this data is what? It's a New York Stock Exchange data, and each record is basically the price of each of the stock at various time periods. Okay, at various times, what was the value of a particular stock? So what you want to do is you want to compute the average value of each dividend. Okay, each stock, each ticker you want to compute the average. For example, CPO is zero point 0.1 plus 0.12, 0.11 plus 0.12 plus 0.13 divided by 3, and that is 0.12. Similarly, for CCS, if you do the average, it will come out to be 0.42 and so on. Now we want to compute this average for this big file. See that? So how do we do that? That we will see quickly. Okay. All right. Let's try to do it quickly and then. Yeah. So here, okay. So the way you learn any new language is see a little syntax, talk a little theory, then see a little syntax, talk a little theory. So that's how we are also going. All right. Let's first load this data. So it's saying that load this particular data in 4 columns like this, and then we will see what happens. Okay. So we loaded this 4 column data into this data set. This data set has got 4 columns, and let's say describe divs. It says that it has got 4 columns: name, ticker, date, and val. All right. Now you can look at what is there inside this data set by dumping it. All right. So it's running, and let's see what happens. Is it running properly or has it halted? Yes. So it has printed the data. All right. So we have loaded the data, and by default, while loading the data, it considers the tab as a separator. Okay, tab as a separator. And since our data was anyway separated by tab, so it happily loaded it. Next is that we can do a group by. We group the data with a ticker, which is this, and then we iterated over the data, and then we called storage. Now you can see that the actual work happened when we said dump and when we said store. Otherwise, it was just accepting the commands as such. All right, so it is working, and once it has done the job, we will see what is there. All right, we will say cat averaged. All right, let's see what happens. Now let's see, is there some folder called average? Yes, it is there. And now let's see what is there inside averaged. Okay, avzd, that's correct, right? Let me just copy paste it. Yeah, you can see that it has computed the average. All right, so you can try to execute these commands. Even though you don't understand it, you will get at least some hang of what does Pig Latin looks like. So Ravi is saying load is like creating temporary table. Not really. Load is more like noting down where is my data. What will explain will do? Explain explains the data information about the data type. Okay. Now, when we say, is it storing table? I mean, when we say store, it took this data took this data which was there and then saved it into a folder called avgd. Now you noticed some things. The output is in the same format, part dash r00, right? It's in the same format what we had been doing in MapReduce. So effectively is the output of the MapReduce. All right. So that's a very quick script, and then we will take a break. Okay, and back by 10 or 18 p.m. IST. All right. Hi, so I'm back. Should we start now? All right. So there may be semicolon after some lines, and there is no semicolon after some line. It's okay. Okay. It's in either new line or semicolon. It accepts it. All right. Good. Thank you, Pavan, for letting me know. But yeah, semicolon is just optional at the end of line. All right, so let's talk about the data types in pig. So the data types in pig are very similar to what data types we have in Java. It starts with integer, then long. Integer is 32-bit, and integer and long is 64-bit number, and a float is 4 bytes. Okay, 4 byte is which is float is 32-bit, and double is again 64-bit. Char array is a string, while byte array is a binary data. So by default, if pig can't detect the data type of something, it marks it as byte array. And and if you have to define something as a string, you can say char array. All right. So and pig also has something interesting, which is complex data type. While loading the data, you can load the data into these complex data structures. Okay, there are three kinds of data types. First is map. Map is a collection of key value pairs. The key is supposed to be character array, and the value can be another complex data type or simple data type. All right, either the scalar data type or complex data type. That is the definition of map. So every variable when we are loading, it could be of this kind. Now, what is a tuple? A tuple is kind of a row. When we say row, it has got fixed length, it's an ordered collection, it's made up of fields and their values. Think of it as one row in RDBMS. Okay? All right. Now, so when we are defining a tuple could look like this. So here a tuple has first column. So tuple is like a row. Each column is either a character array. You can see the character array, number. This is float, and then this is a complex data type. Okay, this is a complex data type of type map. It could be a bag or it could be another one. So tuple is a fixed length ordered collection of made up of fields and their values. Now the third complex data type is bag. Bag is something like a big table. Bag is an unordered collection of tuples. Okay? The way table is a collection, unordered collection of rows, similarly bag is an unordered collection of tuples. Okay? The important property of the bag is that if it doesn't fit into the memory, it is split over to the disk automatically, right? So the serialization, everything is taken care by pig itself, right, Veena? Now that is about the data types in pig. Before we move forward, we have a question from Randhir. Question is, I do not see a date data type. Do we ever need to process the data based on the date? Yeah. So the way we tackle dates in Pig is by using functions or UDFs in Pig. Okay. You use the built-in functions to handle the date. All right. So date is not really a data type provided in Pig. All right. Now, can you show one example of date built in? I'll show you once. Okay. I'll show you once we are there. Just remind me once. We will be talking about the UDFs. All right. Now, when we create a table in the database, we create the table with columns. Okay, we define that this column is of this data type, this column is of this data type, and so on. And that is very important while we deal with SQL. But that's not the case with Pig. Pig is okay even if you don't know the data type of various columns in the dataset. If you do not know, if you do not know even the number of columns, that is also okay with Pig. All right, and that's why Pig is known as the Pig is known for handling the semi-structured data. All right, so you can either tell upfront that hey, my table is of this data type. Okay, here we are saying dividends equals to load this particular file as these columns. All right. Here we are saying that exchange is a character array, symbol is a character array, date is a character array, and dividend is a float. Okay. Or you could simply say exchange, comma symbol, comma date, comma dividend. Or you could simply avoid all of this. You could just simply say dividends equals to load this. And it will try to do some guesswork if you do not provide the data types. Now, when you are defining a data, here we were happy, like here we just defined our column as scalar data type called char array. But sometimes you might have to define a particular column as a complex data type. Okay, as a complex data type. For example, A could be a map, or we we could, let's say, we could define A as a map. All right, or we could go one step further saying my A is made up of map which contains the value as a tuple. Okay, value as a tuple. Okay, so it's a map of tuples in which key will always be a string and the value will be a complex tuple. Okay, we'll take an example very quickly after this. All right, now similarly, we could also define some column as tuple without any data type, or we could say Okay, my field is a tuple having two columns, namely x and y. Or we could go into further detail and we could define a column like my column A is a tuple where there are two columns x and y, and x is an integer, y is a byte array. Alright. Similarly, while defining something as a bag, you can either say my column is a bag, or my column is a bag of tuples whose data type who bag of tuples having two columns x and y. Or we could define in a very simple way like my bag is a tuple my bag my bag contains tuples. My bag is a collection of tuples having only two columns x and y. So you can be very go detailed while declaring the data types of the columns, or you could skip some of the declarations. You could be vague. All right. Now you can cast you can cast one data type to another if possible, similar to Java by affixing the data type inside the brackets. For example, brackets int. Okay, you can do that at a later point of time. All right. Now Veena is saying, so we can alter the number of columns in an existing table. Just like just like in SQL, we say projections by saying select. In the same way, we do the things here. We use for each. All right. Naveen's question is any practical use of map tuple versus scalar data type? You will see it soon. Okay. Ravi's question is can I specify UDF class for a column? Yes. A custom class. Yes, that's correct. All right. So while we will be loading the data from external sources, that time the classes will be created. All right. Now going ahead. All right. Now let's take a look at something very simple. The basic command called load. So here we are saying load my data from dividends into this particular. Okay. So you can see divs. So describe divs. It says there is no schema known because we have not declared its schema. Therefore, there is no schema, but you can say dump divs, right? So as a thumb rule, when you are writing the piglet in queries, you put semicolons. If you are just passing a command like dump, describe, explain, you don't need to put semicolon at the end of the line. Okay, now you can see that it has loaded this data from that file. Okay, now sometimes your data could be comma separated. In those cases you could say load NYSE dividends and using big storage comma. Okay, you could say that. If you're trying to load the data which has comma separated, you can use this. All right. Now also please note here that we are providing it absolute, and sometimes if this file is located in your home folder, you could simply say this, or in the current folder. You can also see that there is a command called pwd and cd. Now this is my current folder. All right. This is my current folder. All right. We can load multiple files into divs. Okay. We can load multiple files by saying nysc underscore div and start, and it will load all the files with this name, this prefix, into divs. All the data concatenated together. All right. Now, sometimes you may want to load a database table here by using, if you want to load a table from HBase, you can say things like divs equals to load this table using HBase storage. And you can load the HBase table this way. All right. Now, while loading, you can either declare every column in detail, or you could just do this. Okay, if you are declaring all the columns in detail, then when you say describe, it will show you all the details. Sometimes you want to load the data from other formats like JSON. Okay, in those cases you could say my div equals to, or my table equals to, load my JSON using JSON loader, and there we can specify the column name, and okay, so we could specify the fields of the JSON and their corresponding value using their corresponding columns into what will be created in pig. So basically we can load data from many sources into pig. All right, so this JSON loader is inbuilt, so we don't need an external jar files to be added. All right. But if we are trying to use some third-party library to load the data, then we'll have to add that jar in the pig. Alright, so that was our load function. We tried to load some data. Now, if you want to see what's there inside a dataset, you can either say explain or you could say describe. Describe tells you only the column names and their data types, while explain tells you the complete detailed plan of execution. So if you say explain divs, it is showing you the execution plan. All right, it is showing you the execution plan. You can see that load this. All right. Right. So that is explain. All right. If you're using big too often, then you can use any syntax highlighting tools, such as there is big eclipse, there is emacs for uh, big Latin for emacs, and then there is a bundle for textmate, and there is a script for vim. Now there's a question from Veena. Let me just answer that question. Question is, what will happen when we split a table to store in HDFS? What will happen when we split a table to store in HDFS? I did not get the question. Do you mean to say that when a table is going to get stored in HDFS, it will be broken into blocks underneath? So it doesn't matter honestly. For it, pig is just a client of HDFS. And what does client get? The overall full file. Okay. So therefore, pig doesn't bother too much about the internals of HDFS or the MapReduce. All right. So Sridhar's question is, when we say describe divs, it is saying that the columns are unknown. That's correct, because when we loaded this data, we did not define the columns. Okay, when we loaded this data, we did not define columns, and that's why you are seeing this. But if you define it like this, okay, all right. Now let's say, so now if you say describe divs, then you will get the details. You see that? Sounds good? So Ganpati's question is, are tables stored in HDFS blocks as well? Actually, there are no tables here. When we say divs, this divs is basically a symbolic representation of this load. Okay, so when you say dump, at that time whole MapReduce runs and does the computation. Right now it's just a symbolic representation of this particular statement. All right, so there is no storage happening right now. All right, so that sounds good. Good, that's correct, Ganpati. You can also define columns without the data type, and in those cases everything will be binary array, binary data, which is byte array. Okay, so moving ahead now, after the divs, after the loading, you could say store or dump. Store stores the data. Okay, store stores the data into HDFS. If you are running in local mode, it will try to store the data in the local file system. If if we are running in normal mode, which is without any minus x local, meaning without any extra arguments, it's talking to HDFS. And when we say dump, when we say store, it stores in HDFS file system. And the way the syntax is, store divs into some file, and you can give absolute path or you can give relative path, and then using pig storage. If you want to store the file as comma separated, then you say this. Otherwise, by default, it will store as tab separated. So Sridhar's question is, can we override divs with other load function? Yes. Okay, we can override it. All right. Now there is another function called dump. Dump basically does the print job. We have already used both store and dump. We stored the result into the HDFS, and using dump we have been using it from the beginning to print the data, print the values on the screen. It's useful for debugging. Is you or using the script with redirecting output. So if you want to just save the data printed by pig into local file system, you can basically say pig do blah 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 and then execute dump, and then while you're executing it, you could save the whole output of the pig into a file. All right. All right. So those were the simple load statement. And yeah, now we will take the more detailed one. Yes, like the cat command, you can dump. Yes, Veena. When we say when we want to store our data, or when we want to load the CSV files, or we want to store the data as comma separated, we use using pig store comma. If you want to load the data or store the data as comma separated, we use this, or a colon separated, then we use this. Okay, so that's how. All right. Now there's a question from Randhir. When you dump onto same files, will it overwrite or give an error? You should try it out. Actually, it will give an error. Okay, and the error will be same as when you try to run MapReduce and you provide the output directory as same. Okay. All right. Now relation operations. Now let's start with something serious, which is for each. Okay, so if you want to do something for each record, then you use for each. For each is like select statement, because when you say select a comma b from a table, so a and b columns will be selected from the table instead of all the columns. Or if you want to say select a plus b from a table, then it will sum up a plus b for all the rows, not only for few rows, but for all the rows. So similar to select, we have for each here. For each is not like do while or for loops of any programming language. It's more like a projection. It's more like select statement. All right. So, for example, when we are loading our data from dividends in, we have four columns, and all we want is just two columns out of it. We can say for for each divs is what? This statement. For each divs, generate only these two columns. Let's try to do this. So here, all right, so diffs has been loaded. Now next statement, we can skip the dump because we don't need dump right now. Dump is just to debug the problems. Okay, and then here let's dump the overall output. Now you can see clearly that's beneath the everything, under the hood, it's running the MapReduce. It has created a job and it's running the MapReduce job. Okay, and it is also showing how many combiner and how many reducers are there, C column and all that. Now you can see that it has picked up only two columns out of all of all the data. Okay, so for each is like simple mapper, it doesn't have a reducer. So we can store we can store values into values. So I'm trying to store the output of this values into values. Sounds good to you? Yeah, it has finished. Now let's say what is there. ls. Do you see any column called values? Yes, there is a directory called values. And let's say what is there in that directory. Now there is something you should notice clearly. What do you see here? Part dash m dash 000, which means this result has been stored from the mapper, and hence there was no reducer. Correct? So you can see that since we are just iterating over the data from, so if we have to do this by ourselves manually, we will have just the mapper. We'll have just the mapper which will read the data from the input file and then generate the output, and there will be no reducer in the game, right? you and that's why there was, you see, part dash m. In case of reducer, this, instead of m you will have r. Okay, and you want to see what is there inside it, you can see. So by default it has stored as comma separate, tab separated, so there are no reducers. All right, so Vina's question is, it is already in values, so this values is not a file, it is just a variable representing this step. Okay, when you say store values, when you say store values into values, then we are trying to put this data into a file called values. We are trying to we are trying to load this and then do the computation and then store it. All right, good. All right, Ganpati, that was a command. Do you want the command from me? Let me just send it to you. All right. By default, I'm sending it to all. No worries. So good, good. All right. So you should always keep an eye on the MapReduce. The reason why we learned MapReduce is not because we'll be writing MapReduce too much, but we should understand what is going beneath Pig Latin, so that you can optimize your Pig Latin. You can understand what is going wrong. So the values in line 3 does not store in HDFS. You mean this one? No, it doesn't. These are symbolic names given to these statements. Okay? These are like views, the way you create views in SQL. Okay? And in SQL, when you create views, they exist in the file system. Here, they don't exist. If you exit pig and then you start pig again, there will be no divs. All right. So Vina's question is pig slower than MapReduce? Not really, because it'll be the same thing. There'll be only like 1 milliseconds difference because it takes time to generate MapReduce from your query. All right, Ganpati is saying the cat is giving error. Look at the folder. Don't try to do the cat on a folder. Do the cat on the file. Okay. So here, this is the statement number fourth is going to create the HDFS files. Okay, fourth one. Just that the name I've kept same so that you don't get so that you get confused. Actually, we could have said this. Okay, no, never mind. All right, so that was our for each statement, and it gave us a lot of clarity on many things. First, we loaded data, and then we iterated over records, and then we stored the values. Now, the interesting part, you would be surprised to know that when we say any of these statements, if you notice, nothing happens. Do you see that? Nothing actually happened. It just made a note of what we said. It just made a note of what he said, that okay, fine, div means loading of data. That's all. The actual action would happen not here. You see, again, if I say this, nothing happened. It just made a note of okay, values means for each something, right? But when you say store, then the real game starts, and these strange characters would come. Now, when you say store, then it starts processing. You see that? So it is the dump or store which makes the processing happen, which launches the MapReduce job. Unless you say dump or store, it doesn't do anything. Okay? Unless you say dump or store, it just keeps on making a note of okay, div means this, values means this, and this data set means this, and so on. The real magic starts the moment you say dump or store. This is called lazy evaluation. It's evaluating when we are saying dump or store. It's not evaluating as and when we are typing command. Unlike in Python or unlike in any other R or something where whenever you type a command, it evaluates. Here, that's not what is happening. Here, it's just making a note of, okay, fine, divs means this, values means this. We will not take any action right now. But the moment you say store, then it starts running the full MapReduce. And the reason of this behavior is since MapReduce is a batch-wise processes, it creates the whole thing as a batch. So very good question, Veena. So we will not know if there is an error in our script until we say dump or store. If there is an error, syntax error, then it will tell us. You try to do a syntax error here. Let's say we are saying values equals to something like val 123. It is saying error immediately because it knows the data type of divs and it doesn't have val 123. Therefore, it is giving projected field does not have a schema. All right, but it doesn't do the value evaluation. Okay, it just checks for errors and that's it. The real data related problems will not be caught. If there are real data related errors, say you are computing summation in the projection. Let's say going back to what we are doing. So let's say here we are we have loaded name, ticker, date, and val. Let's say we are saying generate ticker into 2. Okay, generate ticker into 2. Let's see if catches these error or not. Fine, this is okay with it. It says that there is a warning that it is trying to implicit cast into integer. Why? It has detected that you are trying to multiply a byte array with 2. So maybe it will try to cast it into integer. And the moment we say dump values, then the whole thing will start giving us errors. Okay, it's executing, and when it runs this part where it's generating this, then it will show the errors. Okay, so you can see that it basically skipped everything. There was an error in the record, and therefore the first column didn't appear at all. Alright. So question from Randhir is, can we do the combiner in Pig Latin? Pig Latin will do the combiner by itself internally. Alright. So that was about a very good discussion on Pig Latin. I'm hoping that every one of you is with me. Alright, let's go into a little bit more details into for each. Let's say you have loaded this particular file. Let's first have a look at this file, okay? Then we will try to load it. Let's say cat this. You can see there are so many columns. Now let's load this. Alright, so we have prices. Now we can select, we can do some kind of mathematical operations on the columns. You can see we can say things like this and say dump gain. Similarly, we could do dump gain too. In if we have not given any column name. If we just had written price is equal to this much and we did not specify any columns, in those cases we could actually use $6 and $3. 0, 1, 2, 3, 4, 5, 6. So $6 means close and $3 means open. Alright? So if we don't want to give, or if we have not given any columns, then we could use this. Now you can see that it has computed close minus open value, right? And all of this is happening through MapReduce. All right. Now, sometimes you want to select all the columns starting from mm, the beginning till open. In those cases, you could say for each prices generate dot dot open. Or if you want to select all the columns starting with open till the close, you could say open dot dot close. Now sometimes you want to uh, just print all the columns after volume, starting with volume, then you can say for each price generate volume. All right, is my voice clear to everyone? Ganpati is saying that my voice is gone. All right, so it's clear to Veena. All right, so maybe there was some fluctuation. So, okay, so where did you miss from? Where should I repeat from? So, I was trying to explain how you could select the ranges of columns. Okay, so you could put dot dot and then say column name that will basically select the range. Okay, sounds good to you? Now, question to all of you, will it have any reducer generated? Will there be any reducer task? Gain equals to for each prices generate call close minus open. Anybody? You remember why we needed a reducer? When we needed sorting or grouping, then we needed reducer in our actual logic. But here, all we are doing is translating the input from one form to another, and that's it. There is no grouping, no sorting involved. Therefore, there is no reducer. Yes, that's correct, Naveen. Only when we do aggregation or only when we do the sorting, then we use reducer. That's correct. All right. Now, there's some more things to discuss about for each. Okay, if your data is in the form of complex data types, then it will take a lot of we'll have to use the we'll have to use these kind of structures. So let's try to first load our data. So I think it'll be there slash data. Do you see? So you see there will be oh, it's not there. It's not there. All right. So where is that old data? All right. So there is this folder called student, which I can say copy to local and copy to local this. It'll take quite some time. All right. So let me try to explain before we go there. All right. So if our when we do the tuple projection for the complex data, we can actually iterate over the details. Let's say we have loaded this input file. An input file contains each column as a tuple containing two tuple contains two columns x and y. Okay, so when if we just want to pick up one of the values, we can simply say b equals to for each record of a, generate t dot x, because t means tuple each record, and then t dot x, or we could say t dot dollar zero if you want to just get into the details of tuple. If we have our input data, let's say a, in the form of the bag is what? Bag is a unordered collection of records, unordered collection of tuples. So if you want to get into this, let's say out of this bag I only want b dot x value. In those cases we could say for each a, generate b dot x. Okay, so it has done the copying. All right. Now, sometimes you want to uh, take two variables out of the bag. So A is made up of A's each record is a bag. Okay. This bag contains tuples which has three columns. Now you just want to generate newer dataset containing containing only two columns out of the bag. In those cases, you could simply say things like this. Yes, t dot x will get the value of x. That's correct, Ganpati. T dot dollar zero will also do the same thing. Okay. If you had not defined things, these columns, in those cases, you could use t dot dollar zero like this. Okay. Is B a bag? B is a dataset containing dataset of bags. Yes. So Veena's question is it like a view? You can think of it like a view. Yes. Just that whenever you're creating a view in SQL, the definition of view is stored in the database. When you come back again and connect again to the SQL, you will find the view to be there. But in case of pig, the view is gone if you exit from it. All right. So let's see if I'm able to find student. Yeah, there's too much of data. All right, let me just copy this data to our folder Hadoop FS copy from local baseball. All right, I'm back in the pig. So yeah, now there would be a baseball file here. Let me make a note of few things. Copy baseball file. All right. So we have baseball file now. Let's take a look at what is baseball file. Yeah, you can see that the complex data structure, it shows you clearly. Then let's take a case of this guy. So all I'm trying to show you is how would you do the operation on complex data types. So let's take a case of baseball. So we are loading this file called baseball. It has got these columns: name, team, the traits, and batting history. Okay, so the name of the baseball player, which is, let's say, Ben Joberist. Okay, and then you have Ben Joberist, and then you have batting. Okay, so name and then team. Let's say, what does team look like? Team is also a character array. Good. Traits, what is traits? Traits is a big bag. You can see that. You can see that it's a big bag. It has a curly bracket. That means it is a big bag. Okay, from here till here. See, it's a big bag containing records. You see the round brackets? Those are the records, and these records have only one column. All right. Now, as the batting average, so that was the character trait. The batting history is an kind of a hash map. Okay, kind of a map. You can see that it shows that number of games plays is 64. if you look at other players' batting history, it says at bats 193 times, GDB 1, games played is 255, and so on. You can see that. So we have all these details about these players in a complex format. We can load this data, okay? We can load this data easily like this. So we can say describe B ball. So it shows clearly that it has these are the data types which we gave. Now let's say we want to just pick up the name of the player and their batting averages. So all we do is for each B ball, generate name and bat hash the key name. Okay, so that's all we want to generate. Now since it will start the action only when we say dump. All right. So it is starting the process. You can see that. Now, Ben Jobrist has 0.26 while Joel Jumaya has nothing. So it has picked up those values from the file. Sounds good to you? Batting average of all. So it has converted a complex structure into a simple structure. So that is the role of projections, or that is the role of for each. Sridhar's question is, can we do this cat file name head minus 5? No, actually that's valid only for shell. If we are using shell, pig does not have this pipe functionalities. So Naveen's question is when to use bag versus map in baseball. So simple idea is that map is a key value pairs while bag is like a big table. So you can understand that the big table is having more details, okay, of about columns and rows, right? Bag has records and record has columns, but in case of map it is basically like a big hash table. So mostly, um, whenever you are trying to combine the key value pairs, then you use the map. If you are trying to handle the records kind of a situation, then you use the map. Then you use the bag. Vinay is saying, so it is not sorting the data. No. When there is no reducer needed, it doesn't sort the data. Okay. So Randir's question is, can we define XML data? Yes. There are XML pig loaders. Okay. There are XML pig loaders. Sounds good to you? All right. So here we are. So we are loading NYSE dividends as this, and then so that was dealing with the complex data type. We could deal with the complex data type. You could also try to do all of this. So sometimes you want to do the computation of the record. Okay. For example, here we are translating the data into something else by multiplying 100. Okay. So you can do all of these things. Now, when you're doing multiplying things, you're generating new columns. You can give the column name or you can just skip giving the column name. It is totally up to you. All right. So you can see that if we do this, And then, all right, and then we say, so it shows that dividend is double and double. Okay, so it has figured out the value. So it's completely okay whether you want to give a new column name to the newly created column. All right. So a detailed function list you should see here. Okay. All right. There are a few more things I want to go with. All right. Now the real story starts. So given a data set, now so far we only talked about loading the data set, selecting few columns, and storing the data set or printing the data set onto the screen, right? So we talked about for each, dump, and store and load. Now, if you want to group your data by something, you can quickly do that using group by statement. So you could say B equals to group A by F1, all right? Or we could group it by multiple columns. We could group it by multiple columns. What's going on with this? I'm sorry for this. Just give me a second. All right. So we could say B equals to group A by F1 or group A by F1, F2, group A by H. Okay. Now let me first try to. These are other examples. Yeah. Let me just put it somewhere. All right. Now you can see that. So this is my data set called A, which contain John 18 and some floating point number 4F and so on. Right? This is my data set. If you see the column names, you have name, age, and GPA. Okay. Now, if we group this data by age, okay, what would happen is now the each of the records in the data set would be having first first column as the age, okay, and the second column as the bag of all the records whose age is 18, whose age is 19, will all they be grouped as a big bag here. Similarly, so for 20 there'll be a bag with only single value. Here also the bag will be of having single value. So basically when we do group by, it generates a new record in which the first column is the first column is the column on which we did the grouping, and the second column is a big bag containing all the record having that particular value. Okay, so you can see here also, so it has generated a new data set called B, where the name of the first column is group, Group group. That's default. And then the new column name for the grouped values is called A. And the bag is having these names of the field. Okay, so this A is a bag of records which has these columns. Okay, so that's how the magic of grouping happens. You can see that grouping is, although it's a very straightforward operation, okay, although it's a very straightforward operation, the objective of grouping is very clear. The only thing I'm trying to focus is how do the data structures look like. Okay, so what happens to the newly created data structure after you group the data? That's what I have been explaining. So you can see this. All right, now grouping you can do on one field or maybe on two fields. So you can do the grouping on composite fields. All right, sometimes you want to ungroup the data. When you want to ungroup the data, so let's say you earlier grouped the people by name, now you want to group them by programming language. Okay, so you will have to ungroup it and then regroup it based on the language. Okay, so the way you do it is you load the file like this, saying name is this, language is a big bag, and then you iterate over x, which is our data set. We say for each x and generate name and flatten the language. When you say flatten the language, this bag will, whatever records are there, they will be put in as separate records. So Sandeep and C comma C plus plus will become Sandeep C, Sandeep C plus plus, and so will happen with all the records. Now you can do things like you can group this data now by language. Okay, so flatten is just opposite of the grouping. Now there is something called filter. If you want to select only few records out of the full data set, you could use filter. Let's say we are loading this, okay, and then we are, okay, so we are saying all right, we are saying filter divs by, here is the condition, we are saying filter divs by this condition. So for all the records where this condition is true, only those records will be put into this newly created data set. Okay, so here what does this condition means? It means symbol matches cm dot star. Anybody tell me what does it mean? What all records will go into starts with cm? Anybody? Yes, all symbols that are starting, their initial characters are c and m. Okay, and after that 0 or more of any character. That's what it means. Okay, so you can say dump. All right, so here we have this. You can see that it has only picked up the records which start with CM. See that? CMU, CMP, and so on. That's what is the magic of filter. Okay? Similarly, you could do filter divs by not. We could put a condition as not, and then it will invert the meaning of this. Also, we could put the condition like dividend greater than this and dividend less than this or dividend greater than zero point 0.4. Okay, dividend is one of the columns in the dataset. So this way you could have the complex queries made out of pig. All right. So Veena's question was, is key equals to group and value A? Did you get the answer, Veena? Yeah. All right. All the okay. All right. Now, regarding the date filter, let's what is Naveen saying about the date filter? You could go to the functions, and there you will see the date time functions. It says for general information about this, you should look at the Java code and date time formats. So, all right. Now let me try to have a look at it. All right. Let me try to have a look at it. Okay. Uh, I mean, rather than wasting time now, let me just make a note of it. Okay. Prepare datetime function examples. All right. Yes, that's correct, Sridhar. Filter is equal to where clause in SQL. Radhir is saying you can use regex for date filter. Yes, kind of you can use regex for date filter. All right. But let's have something more meaningful. All right. So we will go into more details, but if you get some time, try to solve the problems available to you in the LMS. If you go here, you will have this subjective assignment. You try to do that, as well as there will be a quiz of Pig Latin. You can take a quiz as well as subjective test. Whatever you can solve, try to solve that. All right. So that's pretty much for today, and we will continue from slide number 37. Okay. All right. Slide 37. Yep. All right. Bye bye. Have a good day. Could you provide us with the cluster installation? Let me update it. Although I had updated it in the previous one. So I gave you a documentation yesterday, I think, whereby I was showing you how to do that. We just followed that simple documentation. It's not too much of difficulty. Okay. So all we did was we installed Ambari server. Once we installed Ambari server, we made it possible. We made it passwordless by copying our SSH key of the Ambari server, and then we installed Ambari agent on all the nodes. Once we had Ambari agent installed on the node, we went back to the Ambari server and said that please install Hadoop on these nodes, and rest of the things were done by the Ambari. Okay. Susant, okay. All right. Yes, Veena, all the class notes up to yesterday have been uploaded. These today's class notes will update soon. Okay. All right. Thank you very much. Have a good day. Bye bye.